Hi everyone, this is M. Sangeeta, Assistant Professor of Physics, Auxilium College of Arts and Science for Women, Raghunathapuram. In this video, we are going to discuss about nuclear models. Basically, there are three types of models available in nuclear physics. One is liquid drop model, shell model, and third one is collective model. In this video, let us concentrate only on liquid drop model. First, what is liquid drop model? So, this model was proposed by Niels Bohr. When he proposed this model, he found some similarities between liquid drop and nucleus. That is why this model named is called a liquid drop model. Let me begin with this session. So, similarities between liquid drop and nucleus. So, liquid drop is obviously in spherical shape due to the surface tension force acting towards the center. Similarly, nuclear is also in spherical shape due to the symmetric surface tension. Second one is the density of the liquid is independent of its volume. So, the nuclear volume is also independent of its volume. Nuclear density is also independent of its volume. Then the third point is the force of molecular force acting between the liquid drop. So, this molecular forces exist only certain range of forces. Beyond that limit, there will no intermolecular force exist between the two liquid drop. So, similarly, nuclear forces also exist between the certain range. It is a short range force, that is why it is act within a certain range. Beyond that limit, there will no exist of nuclear forces. Then next one is when rising the temperature of the liquid, so it will evaporate. So, likewise, when some amount of energy is given to the nucleus, it will form the new projectiles. So, then last one is, so when we oscillate a small liquid drop, it will break up into the two equal liquid drops equal in size. So, similarly, when the nucleus is also break up into the two small nuclei in equal size, that is the nuclear fission. These are all the similarities. Niels Bohr proposed this theory. He found some similarities between nucleus and liquid drop. Next one is liquid drop model. Already I told you this model is proposed by Niels Bohr and he found some similarities between liquid drop and nucleus. So, then he made following assumption. First one is nucleus is a spherical shape, its density is independent of its volume, its molecular forces exist only certain range of forces, and so it will break up into the two nuclei, that is a nuclear fission and fusion also explained by this model. These are all the followings, he made some assumption. So, the next one is semi-empirical mass formula. This model, this formula is proposed by Visakar to finding the binding energy of the nucleus. The binding energy of the nucleus is given by the equation which is equal to Zmp plus A minus Zmn. Z is the atomic number. Atomic number means number of protons. Number of protons. Mp, it is a mass of the proton plus A minus Z. A is the mass number minus Z. Z is the atomic number. So, that is equal to N, number of neutrons. A minus Z is equal to capital N, it is the number of neutrons into Mn, mass of the neutron minus M, it is a mass of the nucleon. Mass of the nucleon means it will add number of protons, mass of the proton plus mass of the neutron, which is equal to minus b by c squared. C is the velocity of light, b is a constant. Using this relation, we can able to find out the binding energy of a given nucleus. So, then nuclear mass also able to find out by this relation Zmp plus A minus Zmn minus b by c square. Using these relations also we can able to find out the nuclear mass. So this formula is called a semi-empirical formula to determine the binding energy as well as the mass of the nucleus. Then we can also calculate the total binding energy. So the total binding energy is represented by EB. B means binding energy. It is a total binding energy. It consists of these 5 terms. These 5 terms, one is EV, it is a volume energy term. So the second one is ES, surface energy term, EC, Coulomb energy term, EA, asymmetry energy, and EP, parity energy term. So let me start one by one. What is volume energy? So the first term is volume energy term. So the large number of the nucleons, so the total number of nucleons are very larger. So that's why it will not easy to remove from this nucleus. That why, so it will need more and more number of binding energy. That's why when we remove from the nucleus, the individual protons and the individual neutrons are not easily removable from the nucleus. That's why the binding energy is greater. So the binding energy is directly proportional to the number of nucleons. When we give the when a number of nucleons is greater, there will be a binding energy is also very greater. So this volume energy is represented by this term EV is equal to AVA. A is the mass number. So mass number means number of nucleons. So binding energy is directly proportional to mass number. So binding energy is directly proportional to mass number. So the number of nucleons maybe increases, the volume energy is also increases. So then second one is surface energy. Surface energy means the number of nucleons are on the surface is very fewer compared to the inside of the nucleus. So it will easy to remove from the surface. So the binding energy is very less. So this surface effect will reduce the binding energy. The surface effect will reduce the binding energy. So this term is represented by ES equal to minus AS A power 2 by 3. So this reduction is indicated by the negative sign. So AS is the constant, is a surface energy term, A is a mass number. So this this surface energy is reducing the binding energy. So that's why it's indicated by the negative sign. Then we move on to the Coulomb energy term. So the Coulomb interactions between the pair of protons or pair of neutrons is also contribute the reduction in binding energy. This pair of protons or pair of neutrons will also reducing the binding energy. That will also lead to the reduction in binding energy. So this will also indicated by the negative sign. So EC is equal to minus AC Z into Z minus 1 A power minus 1 by 3. So in this, so the Coulomb energy, the binding energy due to the Coulomb interactive forces is inversely proportional to the mass number. It will also reduce the binding energy. Then the next one is symmetry energy. Symmetry means lack of symmetry. So maximum stability of the nucleus will occur when total number of protons is equal to total number of neutrons. That means the capital N is equal to capital Z. When this conditions only the maximum stability of the nuclei will occur. Suppose when there is a departure from this equilibrium, so that is the asymmetry energy. This symmetry energy is also will reduce the binding energy. This term is also represented by the negative sign. So EA is equal to minus AA into A minus 2Z whole square divided by A. So this binding energy is also inversely proportional to the number of nucleons. So then last term is parity. Parity means so the maximum stability of the nucleus is occur when even number of protons equal to even number of neutrons. When even number of neutrons and even number of protons are more stable than even number of protons and odd number of neutrons, or odd number of protons and even number of neutrons. So there will also the binding energy, volume energy is given by EP is equal to AP A power minus 3 by 4. These are all the 5 terms contribute the total binding energy. So first one is volume energy term, second one is surface energy term, third one is Coulomb interaction energy term, fourth one is parity, and fifth one is asymmetry energy term. In the combining all these 5 terms, we will get the total binding energy. So, the only contribution to the binding energy is the volume energy term, because it is directly proportional to the binding energy. So, the volume energy term becomes increases, the binding energy of the nucleus is also increases. So, this is represented by the binding energy per nucleon is also, when substitute all these values we already calculated, no, we have to substitute here, we can get EB by A is equal to AB A minus AS A power 2 by 3 minus AC Z into Z minus 1 A power minus 1 by 3 minus AA into A minus 2 Z whole squared by A plus AP A power minus 3 by 4. So, using these relations also we can able to find out the nuclear binding energy. And this is a model graph, it explains the total binding energy. So, when we draw the graph between the mass number and binding energy per nucleon, we will get the total binding energy. So, this line represents the volume energy. So, it is in the positive direction, because so the binding energy volume energy term will increase the binding energy, that is represented in the positive region. So, then this surface energy, it is represented in the blue line. No, surface energy, it will reduce the binding energy, it will reduce the binding energy or reduce the binding energy, that is why it is represented in the negative region. And this term, this sky blue line is a Coulomb interaction energy, this will also reduce the binding energy, that is why it is represented in the negative region. So, the total binding energy is represented in the red line, it is appears in the positive region. So, this is the model graph. Then achievements. So, using this liquid drop model, we can able to explain the stability of the nuclei. So, the stability of the nuclei can be explained by this model, and also radioactive nucleus, suppose nuclear fission and nuclear fusion also explained by this model successfully. So, the next one is it is a very drawback of this model is this model doesn't explain about the magic number category, and also it doesn't explain spin and magnetic momentum of the nuclei, that why the new shell model is arrived in the. Thank you so much. So, we will discuss about shell model in the next session. Thank you.